Okay, let's begin. I went ahead and imported the Blender logo. This is just a mesh. Now we will add a cube. Let's select everything and delete. This will just be a container. Let's call it Geo. Go to the Geometry Nodes tab. Add a new Geometry Nodes modifier. Delete the input. And hide the logo and import it. You can pin this. First, let's rename it to Ice Chunks. Apps. Just ice. Set this to relative. Let's render this. And let's just start with scattering some points. So distribute points and faces. We need about 4,000. Set this to poison disk. Let's change the radius. So set point radius. Let's get a value. Set to 0.02. Like that in here. It seems ready. So after you went ahead and instance your points, now let's instance another set of points. This, and we want way less. Let's go to 10. Let's increase the distance. Now if we sample nearest, we sampled nearest points index. For these, let me show you how that looks like. White noise texture. It should look like something, but don't forget to realize your instance. So now we have this. We can control the amount of fracture by the secondary points, primary and secondary. Let's just see this 99 millisecond. We can just make this. Take still. Now it should play much smoother. Increase or decrease the distance. Let's go with this amount. Get this out of the way. And we will store the attribute. This will be an integer. Let's call it GID or group ID. Get this over here. Add a reroute. Okay. Now let's use a split to instance. Let's connect the named attributes. We call it group ID. And we will store named attributes. It's gonna be an integer, it's gonna be group ID, and we're gonna store to an instance because these points are instances now. And let's connect this. We will use this later. The context all. I have your fractures. This. I like this, seems fine. Add an extrude mesh node. Well, extrude by 0.1. Doing. Delete geometry. This is get the normal. Dot product with the -1 on the Z, so every point that's facing down will be deleted. This over here. So they're empty. Now let's get this. Run geometry. have this. There's an issue with the face rotation. Flip this. Flip faces. Now go as instances. Distance. Again. Split. Faces, because why not? Named attribute, called group ID. We have a 219 instance back. Add a reroute. Let's view this. So add a for each geometry element. It's over here, so this instance. This. Realize the instances. So now we have a single instance. This. Okay, this one. Statistic node. Set this to a vector and connect it to the position. Want the mean. So figure out this. We hide this. Now, okay. Add the points. Connect this to the position and join geometry to our original mesh. So now each instance will have a point in its center. You can do this in another way by converting instances to points. It's the same thing. Let's take this realize instance and set position. Take this and we will subtract it from 0. We connect this over here. All our instances will move to the center. So let's output the points, and the instance need to be turned back into instances. So geometry to instance. Okay. Okay, now to check if this works. Points, add the instance and points. Click pick instance. Like this. By default it will pick the proper instance. So let's remove this. Now it's time to simulate our points. This one, put the points. But before we simulate we need an ocean. So add a mesh plane, add a geometry, not a geometry but an ocean modifier. 5, 12. Okay, so wave should be 1.2. Let's add some alignment. So 0.4. Let's animate this. So hashtag frame. Let's divide that by 20. Looks fine, it looks fine. Let's rename our ocean to ocean. Position by 4. Bring our ocean, set it to relative. Raycast target. This. If we hit, we will go to the hit position. Which point now down. Take the nearest face or attribute or an integer on the point domain, and we will call it nearest face ID. The reason I take face because we can blur the normals, the face, when we take them, so if an instance is over here, it won't suddenly change rotation. This sample index. We want to sample a vector from the face domain. The vector is the position. The nearest index we stored, so named attribute. Nearest ID. Set another set position. This as the position. First unnamed attribute, we'll store a vector on the point domain. Let's call this nearest face normal. For the position, we'll sample the normal. Right. Go, simulate, they'll move, think, right, we just need to scale down chunks. Elements, position, right, find this, scale, this, go 2.2, 2.4, 2.8, okay. Add, multiply like this, or they become or they have less height when they are near the center. Okay, there we go. I managed to split that out. Okay, you can bake those. What? Take this, another bake. Let's bake our instances. Use this bake as a container. Now it contains the instances. So if we come over here, we add instance on points. Like this, or choose pick instance. Okay. Turn on our ocean again, like not. So they move, but they do not rotate. So find rotation to vector. Attribute that we called nearest face normal. Now they are aligned to the vector. Okay. Let's go improve the ocean. Go into cycles. CPU compute. First, get to the material index. So we move the points up. We need to take the logo back. Relative, realize instance. And sample nearest surface. Set this to integer. The integer name will be named attribute, and it's called material index. Here, do this and hide the ocean. With the material index. It's not. Then we can connect this. Government attributes. Set this to an integer, maybe a float. Let's call it an ID. ID. Go back to geometry nodes, add a new material, let's call it ice. Ice. Ice, let's get our attribute, call it MID. Do it, working, because those are instances, so set this to instancer. Let's add a mix node. Let's view the logo. We'll mix between blue, orange, then need a principled shader. Need is you do shader and lucent. It's over here. The hue saturation value. Decrease the saturation to be 0.4. Those later. Filing should have gone with okay, seems to be crashing even. Go to cycles, add a sky texture. Okay, side logo. Let's get more ozone, less air, less dust. Nice and fine. Let's mix this, light. Okay, the light is too strong, so we'll go with 0.2. This should be 3. Look good. Go 0.5. 0.5 should do it. Let's bring our ocean back. Does it look good? Good enough. Saturation. Oh, changing the value, not the saturation. Change this to 0.3. Now it should look something like this. 5 back. Let's do 0.7. Now go to our ocean. Looks bad. Let's add a new material. Let's do it water. But we will not use this ocean to render because it looks like trash. So we'll duplicate it and let's name it render. Let's hide this our first ocean. Need to give it volume. Right now it's just a plane, so go to geometry nodes, hide our geo, add new geometry nodes. Let's call this function volume. Okay. First select the boundary edge, so edge, boundary, base code boundaries, connect the index, set this to a not. This will give you the inverse selection of the boundary edge. And let's extrude mesh. I need more resolution, like 22. And we need foam. FOAM. Set this to 0.1. Okay. Select your geometry nodes modifier. Want to extrude edges. By this selection, a vector of 1. Want to extrude by a value negative 4, for example. Now we have this. Let's scale these down so they all will be in the same alignment. Position. Position on the top part. Position, so we need them keep their position. The X and Y, but the Z need to be -4. So line X, Y, Z over here. Keep the X and Y, but the Z need to be -4. This need to cap this to another extrude mesh. Let's extrude only the top and like this. Okay, set this to 0. Another set position. This time set all their positions to be 0 except on the Z. Top. Now they are all collapsed to the center. Adding measure by distance. Attribute of the output. Maybe this is too much resolution. 18. Work even while playing. Let me show you the difference now between this and this. Go to this ocean, shading. Transparent. Roughness of 0.02. The IQR of water is 1.323. Let's add a mix node, mix shader. Let's mix with a transparent. Want to mix his shadow ray. Control H to hide this. And we want to subtract 0.5. Does is go to render view. It will keep the glossiness. We set this to 0. It will not have shadows whatsoever. If we set this to 0.5, it will have 0.5% of the shadows. And let's mix this again with a use shader. Attribute. Foam. This ocean does not have foam. You can turn it off or on. Okay. It looks like trash, so let's go to our ocean render. See how good it looks. Note that's gonna make it look 100 times better is volume scatter. Let's set this to 3. Pick a color. Okay. Good. We view this over here. This does not look good. And maybe the color is a bit too much. On. Let's view our geo. Let's change the sun rotation to 88. Now it looks like actual water. Maybe set this back to 3. It looks decent. Let's just add a camera. This view. Let's call this logo. This is the ocean that will be rendered. It's missing one thing. We need foam. For that, we're gonna make another mesh. Delete everything. So just be a container. Let's call it white water. Go back to geometry nodes, add a new geometry node. We don't need the input either. Let's get our old ocean, the low resolution. Let's get our logo. Look at this relative. Logo. Instance, let me just take this ocean render, add it to the collection. Ocean render. So to make the calculations easier, let's get this ocean. Just keep those. Hide the logo. Okay. Normal. Again, dot product -1. Let's view this. So we need to foam to start on the bottom. So distribute points and faces. On the number 100 seems to do it. If it's too much. Yes. Value 4.005, 4.01. Do this much. Okay, now it's fine. We need the velocity of this surface. This surface does not have a velocity. No velocity attribute. This was Houdini. You can just add one node. Let's just make it the simulation zone. This sample index vector could be a position. The sample index. So if I play now, it's not moving. If we set position, this position, it will start moving inside the simulation, and what that gives us is we can store named attribute, vector, position, let's call it start position, let's get another attribute, let's call it v for velocity, and let's get a position, we'll subtract named attribute called start position, just to scale that by 9. View this now, it will start calculating and the ocean start moving. So this is the surface velocity which we will need. So let's simulate those particles. Simulation zone, this one. Particles, get the particles to keep emitting, density to 50, geometry here, that now not very random, same time frame. Now have particles, need them to stick to the surface. So without sampling the nearest surface, because that will be too much calculation. So set position on each frame, we will set their position to go down by, let's go with 0.3 negative. We will raycast them up. So raycast target, set this to 1. 10 meters is fine. Repeat this, if their heads, the head position. Now they should remain on the surface. However, they can jump and fall. This 0.1. When the water pushes them up, they go down bit by bit. If they penetrate the surface, they will move back up. Okay, let's keep it like so. That 100, 1000. Okay. Go. Test. Text. Vector on the point domain, and it's called named attribute. We called it v. Scale it. Again, we will set position. This. I'll use this as an offset. Now we move with the surface movement. Try to get rid of this choppiness. And maybe we will increase the resolution, so let's give it 14, 315. Does it play well? Let's see. This one, go back to Whitewater. This. Okay, it's improved. One more trick. Instead of taking the point velocity, because this one will not have a point near it, it will take this point. Let's get rid of this choppiness effect. Let's add a random value, 0.1 and 1. So we'll change every frame. So note this is frame 26. Let's play back. 2, 3, 4, 5, 6. It's less visible right now. Change this to 2. Now maybe not. 0.8, 0.91. Less visible right now, and it smooths over time. Maybe the particles are too much, so I need an age attribute. we can delete all the particles. An age particle is just a standard, it should be default. Store named attribute. Store float, okay. Float will be a named attribute, let's call it A for age. A for age again. Let's add 1 to the age, each frame. Okay. Get over here after all the calculations. Get our named attribute A. It works. It works. Get a random value. It's gonna be integer. $100. That will be the maximum age. And we'll take this and we'll map range it. So each point will have a random value between 0 and between, let's go, 10 and 100. This value will be the age of death. So let's say this point gets a value of 30. When it reaches 30, it will delete geometry. If the age is greater than this value, it will delete. Okay, so we don't want it to delete all of a sudden. We want to scale it down, so set point radius of this one, set point radius, take the radius, we'll multiply it by this, so it will scale down and die. Ramp. Why not? Why use a ramp? Maybe use a ramp. Start scaling only at the end of their lives. These. Now, seems fine. Okay, mess that up. Now we need this to be 1 to 0. So they will start with scale and they lose it, not the other way around. Now, fine. Okay. All this is a death mechanism. Original chunks before we realize them. So points, instance points. Now we have this. It reads realized data and input geometry is ignored. I have no realized data. Ignore this. Points. Add, subtract this from the position. Let's switch those. So this for the distance. Let's add a map range. Play. That looks okay. So we need them to move away from the instances. So from 1 to 0, if he wants too much, 0.3. Set this to smoother step. Use it to scale this vector, so this vector will push them away from the ice chunks if they are 0.3 meters closer, and the closer they get, the more they're pushed. Scale this again, bonus power, offset position, here, this to the offset. Play this, see, too much, set it to 0.1. 0.1 is just the magic number, it always works. Now it looks like an actual white water set. Two. Okay. Flow goes back. Good. Keep the material. So if you're using cycles, you can give materials to your points. Material. New materials, go to white water, put it right here, shading tab. What I found to work is a mixture between a emission shader, step 1, mix, the transparent shader. Set this to 9.5. So this is like 5% emission. Okay, let's let it play. Let's take this frame, get our ocean render. Let's hide this pathetic ocean. Good view. We don't see anything. Right. This works for you, it's fine. 12.95. 5 seems to do it. Add another mix shader. This time I'll mix 8.1 with a diffuse, and that's the setup I used. Maybe go to a different frame, stop this so we can render faster. Okay, seems good. Get closer. The ocean again. Five, one. Work. that's basically the whole effect. Done in under, I don't know, a few minutes. So, yes, I'll see you in the next one. I will provide a file containing a demo and contains the whole effect. Okay, have a good day, bye.